Welcome back to Mr. Vaughn's classroom. If you could, please take a moment to hit that subscribe button so that you can get notified anytime I post more material. And if you find this video informative, please give it a thumbs up. Today, we're in Unit 4 on functions, Lesson 11, Domain and Range, Part 2. So we're going to pick up where we left off in the previous lesson and look more into domain and range. Our learning goal today is to analyze graphs of functions to learn about their domain and range. We have one learning target today, so as we work through the practice problems, keep this in the front of your mind. If at the end of the lesson you don't feel comfortable making this statement, leave me a comment below and I'll get back to you with any clarification that you need. So our learning target today, when given a description of a function in a situation, I can determine reasonable domain and range for the function. In other words, if you're given a word problem, can you think logically about what types of numbers would be allowed as your inputs, your domain, and what types of numbers you could possibly get as your outputs, your range? First glossary term is domain. This is all the possible numbers that could be used as your input or your x value. So you want to think about what the situation is. Are you allowed to use negative numbers or zero or positives? Are you allowed to use whole numbers, partial numbers? Is there a minimum amount? Is there a maximum amount? These are the types of things you need to think about for your input values to come up with your domain. Next, we have range. Range is the output. So any types of numbers that you could possibly get as an output value or your y value. So think about the situation, think about it logically. Would your outputs need to be negative, positive, zeros? Would they need to be whole numbers? Would they be allowed to be partial numbers? Would they need to be multiples of something? Think about logically, in the context of the situation, what type of numbers you could get as outputs, and those output values are going to be your range. Now we can begin the practice problems for Unit 4, Lesson 11, Domain and Range, Part 2. A child tosses a baseball up into the air. On its way down, it gets caught in a tree for several seconds before falling back down to the ground. Select the best descriptions of the range for this function. So we need to make sure we understand that they want the range, and that is going to be the y-axis. Okay, we're looking for our outputs. What we're really trying to understand is the lowest point on the line and the highest point on the line. So we want to look to the left, and we see that the lowest value is 0, and then the highest value is somewhere just above 12. So now we're going to look at the statements and see which one is correct. A says the range includes all numbers from 5 to 12.5. Well, 5 is the y-intercept, but that is not the lowest value for y. So A is not correct. B says the range includes all integers between 0 and 12.5. Well, integers are whole numbers. So integers are your counting numbers, your 1, 2, 3, 4, 5. But we see that this is a solid line throughout the entire function. So it's not just the integers, it's all the numbers, even those partial numbers. So it's not B. C says the range includes all numbers from 0 to 8.5. Well, that gets us the smallest number, but it only takes us up to this point where the function flattens out. It leaves out all the numbers in this first peak. So it's not C. Choice D says the range includes all numbers from 0 to 12.5. And that would be the correct answer. We don't want just the whole numbers. We want all of the numbers. If you have any questions about this practice problem, please drop a comment below and I'll get back to you with any clarification you might need. Our next practice problem: to raise funds for a trip, members of a high school math club are holding a game night in the gym. They sell tickets at $5 per person. The gym holds a maximum of 250 people. The amount of money raised is a function of the number of tickets sold. Which statement accurately describes the domain of the function? So I want you to notice those key words again. Is a function of. Anytime you see that, the first thing, amount of money, is your output. And what comes after those keywords, number of tickets sold, that is your input. Now we need to look at what it is they're asking for. They're asking which statement accurately describes the domain. Remember, domain equals inputs. So we are talking about the number of tickets sold. When we look at choice A, it says all numbers less than 250. Well, all numbers less than 250 could be negative, they could be 0, they could be partial. And if we are talking about number of tickets sold, we can't have things like negative tickets sold. We can't have things like partial tickets sold. So A would not be correct. B says all integers. Well, this helps us with having whole number tickets sold, but all integers is also going to include negative whole numbers. It's also going to include whole numbers that are greater than 250, and the gym holds a maximum of 250. So we cannot say that it's all integers. C says all positive integers. This gets rid of part of our problem. Now we don't have negative whole numbers to worry about, but This still allows us to sell more than 250 tickets, and the gym holds a maximum of 250 people. So C also isn't true. D says all positive integers less than or equal to 250. This is what we're looking for. It gets rid of our negatives. It stops us at the maximum of 250 people, and it makes sure that we're selling whole number tickets. So D is the proper answer. Our X can be less than or equal to 250, but it also has to be positive whole numbers and be less than or equal to 250. So D is the proper explanation. If you have any questions about how to take a word problem like this and narrow down exactly what describes the domain for that problem, please drop a comment below and I'll get back to you with any clarification you might need. Our next practice problem says Lynn completes a 5K using a combination of walking and running. Here are 4 graphs that represent 4 possible situations. Each graph shows the distance in meters as a function of time. Match each description with a graph that could represent it. So I want to put a few notes here. It says walking and running. So running is going to be a steep line. Walking will be a shallow line, and stopping will be a flat line. So as we're reading through these descriptions, this is what you want to keep in mind. The faster they're running, the steeper or more straight up and down the line will be. As they're walking, that line is going to start coming down and being more shallow, and if they stop, it's going to be completely flat. So now we can look at the descriptions they give us. In description A, Lynn starts out running, so we want a steep line, but then slows down to a jog, so we should see that line start to shallow out. After 10 minutes, she stops for a water break. We should see that line go completely flat. She then runs the rest of the way. So as I'm looking for this description, I see graph 4. She starts running, so it's steep. Then she slows to a jog, so it shallows out. Then she stops, so it's completely flat. And then she runs again, so it gets steep. That means A matches graph 4. Now we can look at description B. Lynn starts the race walking, gradually getting faster and faster. So what we should see is a line that starts out shallow and just keeps getting steeper and steeper and steeper. And that's what we see in graph 3. We see her start walking and then get faster and faster and faster as this line gets steeper and steeper and steeper. So that means B matches graph 3. Next, description C says Lynn jogs at a steady pace for the entire race. Remember, steady pace is the same thing as a constant rate, so we should see a straight line. And that's what we see in graph 1. There's no slowing down, there's no speeding up, there's no stopping. It's the same pace the entire time, so C matches graph 1. And finally, description D, Lynn starts out walking, so we want to see that shallow line, then moves to a steady run, so we should see that line get steeper. After 15 minutes, she stops to stretch for a cramped leg, so we should see that line completely flatten. Then she walks the rest of the way, so we should see a shallow line for her walking. And that's what we see on graph 2. Here she's walking, then she picks up the pace to a run, she stops to stretch out the cramp, and then she begins walking again. So description D matches graph 2. If you have any questions about how to take descriptions and match them to the graphs that they are describing, please drop a comment below and I'll get back to you with any clarification you might need. Our last practice problem says, the graph of H shows the height in meters of a rocket t seconds after it was launched. Number 1, find H of 0. What does this value represent? Remember that with function notation, we have name, then in parentheses, we have the input, and sometimes it equals the output. So if we're looking here, 0 is the input, and we can see that our input is time. So we want to go to 0 seconds, go up until we hit the graph, and we see that that happens right here at 15. So H of 0 equals 15. They want to know what this value represents. Well, it represents the height of the rocket when it starts is 15 meters. So it is launching from a height of 15 meters above the ground. Now, number 2, describe the domain of this function. Remember, domain equals your inputs. So we want to find the lowest input, which is here at 0. And we want the biggest input, which is right here at about 4.75 maybe. So the domain is 0 seconds to approximately 4.75 seconds. Number 3, describe the range of the function. Remember that the range is your outputs. So we want the smallest y value, which is down here at 0, and we want the highest y value of the graph, which is here at 35. So the range is 0 meters to 35 meters. And finally, number 4, solve h of x equals 0. What does this value represent? Remember, in function notation, what it equals is the output. So we want to find the output of 0, which happens right here at the end when the rocket hits the ground, and we can see that happens right here when x is approximately 4.75. So we will say h of 4.75 equals 0. And what does this value represent? The rocket hits the ground at approximately 4.75 seconds. If you have any questions about this practice problem or any of the practice problems that we went over in this lesson, please drop a comment below and I'll get back to you with any clarification that you might need. To finish out this lesson, I want us to go back and review our learning target. When given a description of a function in a situation, I can determine reasonable domain and range for the function. This means if you are given a word problem, you can think about the situation logically and determine what type of numbers are logically able to be your inputs for the domain and what numbers you could logically get as outputs for the range. If you feel comfortable making this statement, you're right where you should be. If you still have questions about this learning target, please drop a comment below and I'll help you out and make sure that you understand before we move on. Again, I ask you to hit the subscribe button so that you get notifications anytime I add new videos. And if you found this video helpful, please do me a favor, give it a thumbs up. I look forward to seeing you in the next lesson.